Good morning, my dear students. So we have done exercise 6.2. Some of the last questions are left that I have shared to you. What will be the solution of those last questions? Okay, so you can do those questions. The simple algebra is there. So today we are going to start the new topic, that is nature of roots of the quadratic equation, to which you are somewhat well known to this topic, what is called the nature of the root of quadratic equation. So if I write a quadratic equation, the general form of quadratic equation, which says ax square plus bx plus c equal to 0, and the formula for finding, the direct formula for finding the roots of the quadratic equation, that is minus b plus minus under root b square minus 4ac upon 2a. Now maybe if you remember or not, in the 10th class I have taught you one thing, that how can we know the nature of the roots of the quadratic equation. You know, this minus b, this won't decide the nature, that is for sure, and neither this 2a. So the main thing is this in the under root also, and in the under root also this b square minus 4ac. This is the only factor which decides the nature of the root, and we call this as discriminant. We call this as discriminant. It is denoted by this del. So del is equal to b square minus 4ac. Now how this b square minus 4ac decides the nature of the root of the quadratic equation, the roots of the quadratic equation. So if this is in under root, and if I tell you that if in this under root you are getting a more than 0 value, so that means it will definitely give you the real number. If this under root, inside this under root, if you are getting the exact 0, so what you will get, this answer will be 0, and you will get somewhat the identical roots, which I will explain you how. And if you get a less than 0 value, that is in the minus, that is in the negative number line, so this will give you an unreal root or the imaginary root, which we have seen in the complex number. So the three conditions you have to keep in mind. If your del is greater than 0, it gives real roots. If your del is equal to 0, it gives equal. Let us add one more word, real and equal, right? And if your del is less than 0, it gives imaginary roots. You know what is the meaning of imaginary, which we have studied in the complex number. So that is what we have to remember here. Okay. One more thing. For this equation, a shall not be equal to 0. Okay. This is the main condition of the quadratic equation. Okay. So see, we were taking a, b, c are real numbers. That means this a, b, c are the real numbers. Now if I tell you that if your a, b, c are rational number, you know what is the meaning of rational number? The number which can be represented in p by q form. It's like, say for example, 1 upon 2, 4 upon 3, 6 upon 11. These are called the rational number, the fraction numbers. Okay, so if your ABC are the rational number, then you see that how your what will be the nature of the roots of the quadratic equation. Okay, so here is the condition. If ABC are rational numbers, then you understand what is the criteria of finding the nature of the quadratic equation at that situation. So let us take, for if your determinant is equal to 0, it will give the real and rational roots. Okay, so for ABC, if your determinant is equal to 0, then it will give you the real and rational root. Now if your discriminant is greater than 0, then you have two cases. If discriminant is a perfect square of rational number, then we'll get the rational and unequal root. Say for example, if your discriminant is greater than 0, Okay, and you have the discriminant a perfect square of rational number. Say for example, I write 16 upon 9. So this is square of 3, sorry, this is the square of 4 upon 3 the whole square. Okay, so from that, in that condition, we'll get rational and unequal root. So the nature of the roots will be rational and unequal. And if your del is not a square of rational number, then you will get an irrational and unequal root. Okay. Then the third condition is, if your del is less than 0, then you know the pair of complex conjugates we will get. Okay. Okay, so let us start with the questions now. That means exercise 6.3. I again tell you that this 6.3 exercise is really easy, but still will solve some of the questions, because this exercise is depend on the nature of the roots, okay, which is too a easy topic. So no problem. Let's start with this question. You are given with this equation to prove that roots are always real. For you have to prove that the root of this equation will be always real. So I'm considering A is 1, B as -2, and C as uh, a square minus b square minus c square. I've not written small one. Yeah, why? Because you have a b c in the equation, so that is what I am considering it as capital A, capital B, capital. They both should be different. That is why del is equal to b square minus 4ac, b square minus 4ac. Okay, this will be 4a square minus of 4a square plus 4b square plus 4c. This two cancel. Take 4 common. Under root b square plus c square. Now you will never get the negative value up on solving this thing. You know why? Because this is a b square and this is c square. Even if you take the value of b as minus, it will get square and you'll get positive value. And the same case with the c1 also. And if you add, you'll get a real value only. So finally this is greater than 0, so it has the real number. Okay. Okay, so let us understand this question. Find m so that the roots of the equation this may be equal. So the roots are equal. We know what is the condition when the roots are equal. That is b square minus 4ac equal to 0. You have b square m plus 1 the whole square minus 4 into a into c equal to 0. On solving this bracket, we got this, and here equal to 0. On solving this equation, we got m square minus 2m minus 15 equal to 0. Splitting minus 2m as plus of 3m minus of 5m. Okay, and finally we are getting m equal to 5 and m equal to minus of 3. Now you can put the values of this m, you will get a perfect square there. Okay, so that is how we will verify our answer. Okay. Okay, so what you have to remember in this question, that if they change the language of the question in such a way that find m so that the equation is a perfect square. So don't get confused. This is actually the case of the real and equal roots. That is, the discriminant will be 0 in the perfect square. So remember this also. Okay. Okay, let us come to the main, I've come to the 12th question, because I see that there are 14 questions, and on those 14 questions you only need to remember the conditions. What are conditions? Okay, and you have to use those conditions and get the values. Okay, so I guess you'll do it, but I see that you'll find some problem in the 12th one, so I'm explaining you here. If the roots of equation a b minus c x square plus this equation equal to 0 are equal, then show that 2 upon b equal to 1 upon a plus 1 upon c. So let us do this question. So if the roots are equal, then b square minus 4ac will be equal to 0. So that means b bracket c minus a the whole square minus 4 into a into c is equal to 0. Squaring, so it will be b square and c minus a the whole square minus of 4 into ac into b minus c and a minus b is equal to 0. Now apply the formula here, c square plus a square minus 2ac minus of 4ac as it is. Now multiply these two brackets, you will get this equal to 0. Now multiply this b square inside, so b square c square a square b square minus of 2ac b square, and multiply this minus of 4ac inside the bracket, so you will get such expression equal to 0. Now what? After this, so many twists are there, you need to understand it very seriously. See, first of all, I'm writing a square b square plus, then b square c square plus, and this 4 times of a square c square here, plus, how this plus 2ab square came? Because minus of 2acb square and plus of 4acb square will get plus of 2ab square c. I'm arranging it, है ना? 2ab square c, and minus of 4a square bc is written here, and minus of 4ab c square is equal to 0. This 4a square c square I have already written in the front. Now I'm writing this a square b square as ab the whole square plus, I'm writing this b square plus c square as bc the whole square plus, and this as 2ac the whole square. Are you remembering a plus b plus c the whole square identity, which says a square plus b square plus c square plus 2ab plus 2bc plus 2ca? So that is what we are molding that identity into this a square plus b square plus 2ab. But since you have a 2 minus here, so as this term indicates 2ab, this term indicate 2bc, and this term indicate 2ca, and in front of it minus sign is there, and in front, that means your a as well as b, they both are positive. In this, what is the common factor? You have c. As b and a we already told that they are positive, then c must have to be negative. That is why the minus came. So that is how you have to understand from here that one thing, that a, this can be written as b square c square. So see, 2 into a into b, if you multiply you will get. So can you understand, I'm making this minus as plus, but I am giving that minus sign to this minus of 2ac, and similarly this minus I'm writing plus, but I'm giving this as minus, and here also I'm making some correction, minus, because minus of 2ac the whole square is 4ac square, a square c square only. So this whole we are getting ab plus bc minus of 2ac the whole square. If you expand it, you will get this as an answer, and after that this one. Now after this, it's very easy to solve. This is square, it will be removed. We are left with ab plus bc minus of 2ac equal to 0. Take minus 2ac that side. Now this 2ac, what you do, just take it into the denominator of this one. So ab upon ac plus bc upon ac equal to 2. This a to a cancelled, here c to c cancelled. Take b common from the numerator, 1 upon c plus 1 upon a equal to 2. Take 2 in the denominator, so 1 upon c plus 1 upon a equal to 2 upon b. That is how we proved. Okay. So I hope you have understood this question. Okay. Now what you have to do the questions of this exercise, and in the next video we'll start with the relation between the roots and the coefficients. Okay. Till that, do practice, see the examples. Okay. Have a nice day. Thank you. Bye bye. Tata.